Hi everyone. My name is Mohammed Rahman. I'm a postdoc from the University of Notre Dame, and in this talk, I'm going to discuss about SigCap, our work on the crowdsourcing platform for wireless broadband mapping and analysis. And this talk is easy. I try to be quick, and it's not about, unlike the previous one, it's not about AI, but we'll touch AI a little bit at the end. And basically, in our work, that we're trying to benchmark the group. The work of the group is trying to benchmark the deployed wireless broadband like 5G, 4G, and Wi-Fi. And what we're realizing is that in the empirical data here in this research is very essential for consumers and policymakers. For the they have to decide new spectrum and how this spectrum is used, and basically the data that we collected in this the empirical data will help that, and that's why we are trying to use this SigCap as a platform to collect all this signal data and try to show it this whole data. And the other things also, we come up with a new tool at this SigCap data platform, which is built by the Center for Research Computing at Notre Dame. And we're also talking about some case studies that how we use this SigCap in our research. So yeah, SigCap is basically it's just a Wi-Fi app. So it's app in Android, and it collects various signals and sensor data through the Android API, and they are correlated to GPS location. So basically, you get the signal data with the GPS coordinates, and we can easily, when you upload the data, we can easily map and export the data through this SigCap data platform. And the advantage of this is it's just easy. It's just simple to use. You can just run it and then leave it overnight. And there's no root capability. You just install the app and it's just run. But the disadvantage here is that it depends on Android API. And sometimes some parameters is not received correctly. It's sometimes broken when there's a new update, but we'll try to fix it. And these are a summary of captured parameters from SigCap. And basically, we have the 4G and 5G NR parameters fields. If you see the 5G NR has missing bandwidth, it's not available there from the API. And the Wi-Fi captures basically, it captures the beacon that's received by the phone. So you can get the beacon BSSID, frequency, RSSI, and even optional beacon elements like the channel utilization, number of stations that connected to that AP, and the transmit power of the AP. And the latest update, we implement the feature to capture GNSS satellite or GPS satellite information, like the satellite ID, the constellation type, the frequency, and carrier to noise ratio, basically like the signal strength of that GPS satellite. And if you upload the data, you can easily extract from this platform page, data platform. But you need to create an account. So this is this data will be open for everyone, but at least you have to create an account so we know who you are accessing this data. So just quickly, let's do a live demo. Yeah.
So don't use any external sensors, just whatever.
Yeah, just whatever in what's available in the phone. Yeah. We just. So the site is showing you that it's not indexed by Google search or Bing search here. Yeah. Oh, okay, that's great. So These are the data that we just captured today, like this morning even. And you can just map this data. So let's look at the cellular map. Let's see. Oh, okay, wait, that's weird. Did I took, okay, I took the wrong file here. Okay. So let me increase the size of these squares, and let's look at the NR bands. So yeah, this is basically, we drove from Des Moines to Ames this morning, and this is what we get in terms of like 5G coverage during our drive. And we see like there's some spots here that are not covered by 5G. And this is all operator. You can select like T-Mobile. What's the turn T-Mobile? So T-Mobile has less coverage somehow in Ames. So yeah, something like that. Oh, LTE. All, yeah, all carriers. Yeah, it's really good. And the other thing is also the Wi-Fi data. So we have this, let's say, like, let's look at 5 gigahertz deployment around here. And, oh wait, yep, there's no, there's no 6 gigahertz Wi-Fi captured at all in this area. There's maybe not much like deployment, or not much people buying new Wi-Fi AP that's equipped with 6 gigahertz. Okay. Yeah. Yeah, roadside. Yeah. It's also like because of our methodology, and we can export it as cellular Wi-Fi CSV. I'm going to talk about this quickly. Okay. So we just talked about this. Yeah. So we can extract the data. So as I show you, I selected the files that I captured this morning, and I can extract the general CSV, cellular CSV, Wi-Fi CSV. Basically, it's just like the types of it. It's for ease of use of your like data analysis. And yeah, so basically, as I said before, like empirical data is important to have ground truth in this broadband coverage. Like the MNO is always like they give reports of their own network, but it's like biased, right? So it is a good thing to have like independent third party to confirm this. And the Ara platform is uniquely situated in a rural setting, which is like mobile network operators sometimes like give less focus on the deployment at rural areas. So let's say like this is the work that we've been done using SigCap data. So in the Notre Dame Stadium, they just deployed 6 gigahertz Wi-Fi in very like dense. So at the stadium itself, like there's like hundreds. I don't remember. It's like 400 AP that's serving 5 gigahertz and 6 gigahertz. And this 6 gigahertz AP needs to use this standard power modes. So basically, a 6 gigahertz is in the US is split into two modes, which is standard power and low power indoor. So the standard power is you can use it everywhere, but the AP has to supply its coordinates, GPS coordinates, so that the coordinator, like it will be sent to an AFC. So it's kind of system coordinator that it's coordinating the Wi-Fi usage in the 6 gigahertz. But on the other hand, the LPI is the mode that you don't need to contact this coordinator, but it can use low power that is limited by the PSD, but you have to be indoor. what we're trying to do here in the stadium is to study the performance of Wi-Fi and cellular MNO, which in this stadium it is very dense, and it is there to serve the stadium attendees that can be like up to 77,000 people there. And the methodology is easy, so we just do a passive measurement. We just walk around with our phones around the stadium during the game, and also after the game as a baseline. And yeah, so these are the data generated by SigCap, like a heat map here that showing the outdoor RSSI of the SP and LPI. So the LPI is very low here because they're deployed indoor. And from the SigCap data is also we can get the channel utilization. So we see that it's actually the channel utilization of the 6 gigahertz AP is very high during the game. It's about 50% compared to other AP. And we can also check that what's the density of the AP by looking at the unique BSSID, number of unique BSSID. And yeah, so basically what I want to say from here is that we have done this works, and we've published this in the dice pen, and the other stuff I think I'll try to be short. So maybe this last one is on the throughput, where so the football season has already started this year. We did a preliminary measurements during the game using the UCLA downlink, and these are the results that we got from the outdoor bowl and the indoor concourse. We're seeing that the performance of 5 and 6 gigahertz Wi-Fi is actually similar, even though the 6 gigahertz are deployed with 80 megahertz channel bandwidth, while the 5 gigahertz is deployed with 20 megahertz channel bandwidth. So further analysis is needed here. The next one is on the cellular. So there's this neutral host concept in CBRS private network, where basically if you are connected to AT&T, T-Mobile, Verizon outdoors, then you go indoors where there's this private network deployment. It will just seamlessly move your phone to that private network without even you don't need to change anything, but you'll still get a network and still get internet. And what we wanted to do, so we did a measurement in this healthcare facility. So this works has to be anonymized. So this is a healthcare facility where MNO A and MNO B are working with this private network to deploy cellular neutral hosts. And we want to see the performance of the neutral host and compared to the what we say macro deployment of the MNO. And we want to see the building loss or the separation between indoor and outdoor for this spectrum sharing purpose. And what we see here is that there's 22 median dB 22 dB median difference between the neutral host RSRP between when it's indoor and outdoor. And so this highlights the indoor isolation of the low power CBSD for spectrum sharing. And a bit of side tangent again. So we also did these measurements this morning by just walking outdoors in this campus area and taking measurements indoor in this room. So this is on the building loss of network that's deployed indoor. So now we're looking at building loss of networks that deployed outdoors from indoors perspective. So we see that this is a RSRP plot from AT&T on band 66, which is mid-band on the same PCI. and we're taking it indoor and outdoor. And the other is the low band, band 14 on PCI 92. And we see that the building loss is higher on the higher frequency on band 66. Yeah, maybe because it's like it can get a higher loss there because of the physics. And just quickly, so the other thing about the CBRS neutral host deployment, we see from our walking measurements, we see that the MNOA is not performing well. And we can say that that MNO is helped by the CBRS deployment, indoor deployment here. And we see that the throughput, so the throughput here, we're taking from Qualipoc. So this is another tool that we use, but this is like root-based tool, but it has more data. So we can get the throughput, physical layer throughput here. So we get better throughput when the MNOA is served by the neutral host indoor. And lastly, like this, on the uplink transmit power, we also found that when the phone is using neutral host, it's actually using lower transmit power for their uplink. So that's like a argument for like power saving there. And lastly, so this is about the machine learning. So we're trying to do indoor-outdoor prediction based on the signal data that we capture from phones. And lately, like in this latest work that we are going to present on the upcoming Milcom, we use the GNSS or GPS signals that are captured by the phone. Again, like this is not the GPS coordinates, but it's actually like RSSI of each GPS satellites that we can get from the phone. And the importance of this indoor-outdoor prediction is because of the spectrum sharing between indoor and outdoor deployments. And for instance, like the FCC for 6 GHz, as I said, like it introduced indoor limitation where there's the AP cannot be weatherized and cannot have battery power, but you can just like use an extension cable and then just put your AP that's supposed to be indoor and just put it outdoor, right, outside the building. So there's a need that just using the signals that this device capture, can we just predict that the device is located indoor or outdoor? And the methodology is again simple. We take all of our data from SigCap, and we built 4 models. For sake of time, I will skip this, but you can talk to me or the author there, Hussein, about the models. And we're trying to test on the scenarios that we have seen and the new scenarios, new location that's not included in the training. And from the tables here, we receive like good results here, but it's low. The accuracy for indoor prediction is lower, and we think that it's due to the 50% of our indoor data set is collected near windows. So, yeah. So because of that, we are kind of arguing about something different, something better for this problem. So rather than indoor-outdoor, let's say that we define something called containment, because the common definition of indoor-outdoor may not fit the context of electromagnetic isolation, and outdoor location may be shielded from interference because of surrounding structure, or the indoor location can be exposed by outdoor electromagnetic signal, maybe because if you're close to the window. And so we defined 2 focus measurements to illustrate this containment. And for the first measurements, we took driving measurements from South Chicago to O'Hare, and in some place we are encountering the like under the bridge, right? And our algorithm or models actually predicting that as indoor. So this is what you're seeing like as blue dot in this map. And the other measurements, the measurement number 2 is where we did stationary measurements inside the grocery store in South Bend, near large window and inside very inside in the interior aisles. And as we see on the table is that we see that well-contained place that we define as well-contained has less number of observed satellite, GPS satellite, compared to the poorly contained, and also the CNR or the signal strength of this average signal strength of these satellites are lower. So basically, rather than saying that a location is indoor or outdoor, can we just say the location is well contained, which means that the electromagnetic isolation is high in there, or poorly contained where it's like open. All right, so thank you for your attention. Please let me know if there's questions. Thank you.
Any questions?
Yeah, so thank you very much. I just have one question. Do you guys capture the traces regarding control plane traffic, for example, handovers, or registrations or service requests, those kind of things?
Yeah, for SigCap itself, no, but actually like other more complex measurement app like Qualipoc and Acuver Xcal do capture that. So that could be something that you can look at.
Thank you. Thank you. Thank you very much.
Yeah, so the right now, I guess in terms of modeling, do you try these models? Have you seen any anything that's like unexpected, and so on, like when you try to model the behavior and so far based on your extensive measurement?
I think not exactly. It's more of like a gap of data. It's actually because we have the app of the Qualipoc app, we realize that there's much more data that we can get. And that's like not available there in Android API. But we use SigCap as like just quick mapping of broadband, a wireless broadband around the area. Like just a first like initial measurements.
So you mentioned maybe the model, right? To model the signal propagation. So any insight there that you can share? Just high level,
High level.
What kind of, for example, our own study using Era has shown that actually some of the statistical models are quite inaccurate, right?
Yeah.
And the fact you can actually use kind of data-driven approach to.
Yeah, so that's definitely true. So one of our members of our groups also working on the improving clutter model, and there's definitely more like empirical data is needed in that, because like current clutter model is very simple,